Hello everyone, welcome to the ITLS Academy. Today we are going to perform another experiment of adulterative series, that is your detection of the glucose into a milk. We all know that this milk contains a glucose, but if the glucose are added into the milk from the outside source, like from a man-made, then this glucose come in contact, come in adulteration. This glucose act as what? Act as a adulterant. Now, what is this adulterant? Adulterant are simply defined as adding of a substance into a food product to degrade its quality and increase its quantity. When the adulterant are added into the food product become cheaper, and the nutritive value of the food product are also decreases. So the ultimate aim of the addition of the adulterant into a food product is only to enhance the quantity of the food product, enhance the color, enhance the flavor. But what about the quality? What about the nutritional value? Because due to the addition of this adulterant into the food product, ultimately the quality of the product affected, the nutritional value of the product decreases. Okay, so now come to the topic, that is your detection of the added glucose. The reason behind the addition of the glucose into the milk is only to enhance its taste and flavor. Okay, but we all know that if the glucose level is high, then it will increase the blood sugar level into the human body, and blood sugar level also damage the kidney of the human being. That's why it is very important to detect this glucose into a milk product, and this glucose are come in the category of the adulterant. Now for the for performing this experiment, we required this setup and two main chemical that we required. First, that is your modified Bradford reagent, and the another one is your phosphomolybdic acid. This is your phosphomolybdic acid, and this is your modified Bradford reagent. One more reagent that we required is the 10% of the sodium hydroxide, but that 10% of the sodium hydroxide are used in the preparation of this phosphomolybdic acid. Now, first of all, I am going to tell you about that modified Bradford reagent, how we prepare it. For the preparation of the modified Bradford reagent, we require 24 gram of the copper acetate, which is dissolved into a 450 ml of the distilled water. When it is completely dissolved, then we add a 25 ml of 8.5% of acetic acid. Okay, first what we have to do, we take a copper acetate 24 gram and it will be dissolved into a 450 ml of the distilled water. When it is completely dissolved, then what we add? We add a 25 ml of the 8.5% of the acetic acid. Okay, then we cool it at 25 degrees Celsius plus minus 2 degrees Celsius. Then after that, we make up volume 500 ml with the help of the distilled water. And when a sedimentation occurs, then we filter it and collect the filtrate. So this is how we prepare our modified Bradford reagent. This is your modified Bradford reagent. Then the second reagent that we required is a phosphomolybdic acid. So for the preparation of this phosphomolybdic acid, first of all we required a 35 gram of ammonium molybdate. See, this composition is again for a 500 ml of the distilled water, and the composition of that modified Bradford reagent is also for a 500 ml of the reagent. Okay, so we required 35 gram of ammonium molybdate, 5 gram of sodium tangentate, and 200 ml of that 20%, 10% of sodium hydroxide and 200 ml of the distilled water. Now when we dissolve it completely, then we boil it around 20 to 40 minutes, sorry, 20 to 60 minutes. Then we add a, sorry, we boil it at when we boil it during 20 to 60 minutes, so that ammonia will be removed. Then the removal of the ammonia will be checked by using a red litmus paper. After that, we cool it and we dilute it with the help of the 350 ml of the distilled water. Okay. Then after that, we add a 125 ml of the not diluted. We check after checking that ammonia into a solution. We cool down at 25 degrees Celsius. Then we make up volume 350 ml. Okay. We see that what is the volume of that solution, and we make up the volume 350 ml. Then we add a 125 ml of the phosphoric acid, that is in a concentrated form, and after that again we make up volume 500 ml. Okay, here what we have to do, we make up the volume. Okay, so for the makeup of the volume, we use that measuring cylinder by performing this experiment. So this is how we prepare that phosphomolybdic acid. Now we required a milk as a sample, test tubes, test tube stand, micropipette of 1000 microliter or 1 ml, micropipette tip. This experiment are very simple. We take a test tube and add a 1 ml of the milk into it. After that, we are going to add a 1 ml of that modified Bradford reagent, and we put it into a water bath at 100 degrees Celsius for a 3 minutes. After that, we take out the test tube from the water bath and we cool it. After cooling, we add a 1 ml of that phosphomolybdic acid. If this glucose are present, then the solution turn a deep blue color. If we get a slight blue color, then it means that our milk are pure. But if we get a deep blue color, then it means that our sample contain a added glucose. Okay. So let's start the experiment. First of all, we have to take a 1 ml of the sample. Then we required a 1 ml of that modified Bradford reagent. Now we have to, you see that we get what? We get this slight blue color. If it turn into a deep blue color, then it means that the sample are adulterant with what? With glucose. So we have to kept it at boiling water bath for a 3 minutes. So I'm going to kept it. Now we will see the result after 3 minutes. After 3 minutes, I am going to take out the test tube from the water bath. Now we have to cool it rapidly. You can also cool that test tube in a running water, but here I am cooling it by my hand. Now after cooling it, we have to add a 1 ml of this phosphomolybdic acid. If the solution turn a deep blue color, then it indicates that the presence of that glucose. See that we get only a slight blue color. It is not a deep blue color, which means that our sample does not contain any added glucose. The glucose which are already present in a milk is only the glucose, but here there is no adulteration of the glucose are occur. So this is all about the detection of the added glucose into a milk. I hope you will understand, but if you have any query related to this experiment, you can freely to ask me in a comment box, or for a further detail, you can follow the ITLS Academy on different platforms, that is your Instagram, Facebook, Twitter, YouTube, WhatsApp and LinkedIn, and subscribe our channel ITLS Academy on YouTube and get our app from a Google Play. You can also visit our website, that is www.itlsacademy.com. Thank you for watching. Please like, share and subscribe our channel.